Okay. Good morning, guys. Yep. Now go ahead, Kiran. You're asking something?
Yes.
Hmm.
So the question raised on this Cedar IP configuration.
Yep.
So we have Cedar range in the first point, right? Create a new custom VPC with Cedar range
Yep.
10.0./16-bit, and the 16-bit uses for the network configuration. You're saying some.
Yeah. Yep.
So what exactly means the network configuration IP that is going to be used for?
So out of 32 bits, 16 bits are used for the routing information itself. Meaning, so where does it go? Where is the source? Where is the destination? And it makes a lot of hops in between, right? Okay.
So communicate
So
with the
internally,
devices. Communicating. Okay.
exactly. And internally, they call it subnet masking, right?
Mm-hmm.
So it uses for that subnet masking.
Okay.
So, and it's not available for, because when you send, uh, when you send a piece of information, so out of that 32 bits completely, so certain piece, so especially in this 16-bit range, right?
Mm-hmm.
So in this case, what happens is you will be able to use the remaining 16 only for the actual IP addresses. So, and you can make a lot of subnets. Sorry, you can make a lot of sub networks within that using the remaining 16 bits.
Okay. Okay.
Okay.
Mm-hmm.
So if you go with 8 bits, right? If it's /8, then we saw that about 16 million or some
Yeah. Yeah.
crazy number of it.
So basically, you can it uses for subnetworking. So
It-
those IPs will be available for all subnetworking. Okay, mostly
Yep.
kind of. And the
So
Cedar
Venkat,
range, yeah.
Yeah.
so how do you decide the 16 versus 24? How do you decide?
Okay. How many IP addresses do you need? That's
Oh,
that's
okay,
how you decide.
okay, understood. All right, that's what
So
I thought, but I just wanted to confirm. Thanks.
yep, /16 will give you about 65,000, and /24 will give you what? 256, I believe, if I'm not wrong. Yeah, 256. And then out of 256, Amazon keeps 5 of them. So then there's an article I wanted to. AWS reserved.
So Venkat, so we should never give by 32 10.0.0.0 by 32. So you don't can get any.
So we will see that /32 you can give, but that means only one IP address you're talking about.
Okay.
So if you want to give, let's say, what is my IP, right? So this is what it is, 69, whatever this IP, right? So this is our, I have to give it. So if I have, this is my IP address, but if I need to give this one as a CIDR range, then I have to give /32. That means I'm talking about just
Only
one
one
IP
IP.
address. Exactly. I'm talking about one IP. There's no range here.
Then we can't create subnetworks.
No, there's no range here. You're talking about one IP
Yeah,
address.
that's what it will not allow us to.
Yep.
You should
It's
give an
just,
error. It should give a yeah.
yeah.
Okay. Got it.
Yep. So 251 IP addresses, actually Amazon has, yeah, as you guys do it, I'll look for that. So what those 5 IP addresses are, and then how it uses it, Okay, so shall we go ahead and get started? So we have to start with where we, one round we did yesterday. So we want to do the same thing again, and then we will enhance it with a couple more concepts. Okay. So all of you guys, is anyone not ready? Is anyone not ready? Wonderful. Let's go ahead and get started. So let's go ahead and create a new custom VPC. And to keep it simple, let's use the same CIDR range. So I'll be doing it here. So did you guys see this one? Launch VPC Wizard. If you launch VPC Wizard, it just makes your life easy, but I highly recommend you do not use this one. Okay, because you want to understand it. You want to do it in a most fundamental way, so that all the concepts will get stuck in your brain. So let's go ahead and create a VPC, and I'll call this one as custom VPC, or let me call something else. Yeah, we were talking about the weather application, but for each application, I don't create a VPC. So let's build my whole company. Let's say, I'll say next step prod VPC. Yeah. So this is my VPC, and then my CIDR range is 10.0.0.0/0, so /60. And here, this is IPv4 CIDR range is required, but in addition to this, you can also go for IPv6. So this time, just to keep things a little interesting, I'll say yes. Give me Amazon provided IPv6 CIDR block also. So I'll be able to do some IPv6 also.
Venkat, can you give 24?
What's that? Yeah,
24.
Absolutely. You can give 24, but the VPC itself, you have a /24. That means you have 251 IP addresses. Now, how many subnets you can create, right? So let's go to that CIDR.xyz and .o.o.o. If I give 24, all you get is 256. Okay. Then your subnets should be what? Your subnet should be /26. Yeah. So you understand what I'm saying here? So if you give 24, I mean, it works for our use case because across the VPC, the big VPC itself, you are getting just 251. Out of that, you wanted to have multiple subnets. Okay. And each subnet has to be about 26. Then in each subnet, you are going to get only 64. Does it make sense?
Okay.
Just to show you, I will do the /24 just because you asked.
Okay.
So let's go ahead and create /24. Okay, I got that. Because we are only creating anyway a couple of subnets, and each subnet we don't need hundreds of IP addresses anyway. But it's a small one if you get that right. So this is my VPC, and this is my VPC. And what's the next thing we want to do it? And again, we are going to have a public subnet and private subnet. So first thing we want to do is internet gateway. Let's go ahead and create an internet gateway. Create internet gateway. Next, prod internet gateway. Close. It is detached at this point. I'll go ahead and attach it. Attach to my VPC, which is next step prod. So the reason I called it next step prod is because let's say you guys work for Blue Cross. So it's typical that your QA environment will have its own VPC, and production environment will have its own VPC. That's a good architectural style and principle. So that they don't talk to each other at all. You have your complete network isolation. That's the beauty of VPC, right? Are you guys able to appreciate it? How much isolation you're getting? But by leveraging, again, by the economy of the scale of AWS, and you are taking advantage of your AWS scale, but you are getting your own network isolation. Pretty much you have your own data center. So VPC is pretty much, you're getting your own data center with your own IP addresses. So we got internet gateway, and we started with VPC, internet gateway. What's the next step? Anyone?
Route table.
Sure, thank you. So let's look at the route table. And there will be a default route table. They call it main route table. It's already created. And this one, I want my main route table to be as private as possible. I will not attach internet gateway to this one. So I will call it this guy as a private or main route table. You can call it as private, or you can call it as main, up to you, not a big deal. Name is just for you to understand, that's all. This is my private route table, meaning this is main. You are able to appreciate why I call this main, because by default, when a new subnet gets created, it will automatically be associated with this main route table, okay? And the main route table will only have a local route, okay? Oops, this is my next step, Rod. Oh, okay, see this one, guys. I want you to take a look at this one here. Remember, all along we have been seeing only one line here, 10.0.0.0/24, meaning this is our VPC cider range. So all the instances can talk to each other within the VPC is essential idea. The target is local. What is this one then?
IPv6.
Yes,
IPv6.
that's IPv6. Because we asked Amazon to provide, Amazon provided IPv6 cider. So this is for IPv6. This is again the local traffic. No need to worry about it. But anyways, this is, yep, that's IPv6. So this is my private route table. And in addition to the private route table, I'm going to create a public route table. I'm going to create public route table in my VPC. So I have private route table, I have public route table. Very good. And how can I make, go ahead.
You need to attach the internet gateway to public.
Yep. So how can I make my public route table to be truly public? At this point, it is not public. Just because you named it public, it will not be. So let's go ahead and click on edit routes, add route. So I'll only worry about IPv4 here. If you want to do IPv6, you can do a :O/O. So this is all IPv4 traffic must go through the internet gateway here. Yep. So all non-local IPv4 traffic will go through internet gateway. Make sense, guys? Now this is public route table. Now this is safely public route table. Okay. So what's the next step? Anyone?
Subnets.
Yep. The next step is we'll create the subnets. Is everyone active? So the next step is to create the subnets. So let's go ahead and create two subnets. Let's go ahead and create two subnets, public subnet and private subnet. Oh, by the way, in your certification, right? He uses the same terminology. I picked this up from AWS documentation itself, and in the exam also, he uses the same public subnet, private subnet, because he wants you to think like a real-time architect, real scenario questions will be there. So next step prod, well, this is my public subnet, availability zones. I'll put it in 2A. So IPv4. Now, Kiran, we put, based on what you asked, I put /24 as the CIDR range for the whole VPC itself. Now, within that, I have to pick a small piece, right? Meaning subset 10.0.1.0/26. CIDR address is not within the 20. Oops. Okay. So what's the? So we gave 24, right? /24. So this is the these are the IPs, guys. They're unfortunately just these ones. 10.0.0.1. See, that is why it is telling me. I hope you're all seeing my screen. So I tried giving /26 with 1.0 here, 10.0.1.0, and it threw me an error saying that, sorry boss, you can't create it because your IP ranges is /24. You can only get 256 out of 256. Of course, 5 are reserved. So you're only getting from 10.0.0.1 to 10.0.0.254. Does it make sense? So this is your first IP. This is your last IP. So you can do it. Now, let's say /26. Now, if I do a /26, then this is my IP 10.0.0.1 to 10.0.0.62. So what I'll do is, let's go change it 10.0.0.0 /26. Don't assign IPv6. Yep. Now I got my public subnet. Now let's do private subnet. Now we will have a conflict, unfortunately. So availability zone. So this is your 10.0.0/26. Yeah, see this one? Now, I think /24 is a bad idea, looks like. So take a look at this one, because we have already used /26. Since we have used /26, because /26 can go up to this, okay? Now I'm trying to use the same /26. It's saying CIDR address overlaps with existing. So let's see. Even this one will, no. This one also overlaps. So I can't create two subnets.
Yeah, it's clear. It's not me.
Yeah. So let me go back and change it.
Yeah. Just I thought of I tried that example. I thought of understanding more. So that's the reason.
No, it's really good. See, we learned something new. So let me go quickly create next step prod.
But Venkat, if you click on the information on the right side and then in the information bar,
yep.
So they give an example. For example, blocks, so it must be between 016 and 2.
Exactly.
So it's making us thinking bad, like
no, why bad? You can definitely create /24, right? It's just that you cannot create multiple subnets.
Yeah. I mean, it's a disadvantage in the part of design, right? If you don't, I mean, okay, you have to think in advance.
Yeah.
If you need, okay.
I mean, the documentation is not inaccurate, correct?
Yeah.
The documentation is correct. Okay. So he's saying you cannot go below /16. because this is the maximum allowed 65,000 IPs, right? And you can't go above slash 28.
28, yeah.
Slash 28. Okay. So the document is not correct. It's just that, it doesn't work for multiple subnets.
Subnets, yes.
10.0.2/16. Okay. Amazon provided IPv6 tenancy default. Okay, I created it, and then I'll go to internet gateway, create an internet gateway. Okay, I will attach my internet gateway to this guy, attach to VPC, my next step prod. And then I'll go ahead and create route tables. Let's create public. Oh, there's a default route table already for this one. So I'll call this as private route table. Okay. So it just has IPv4 local, only local traffic. Let's go ahead and create a new one. We'll call it public route table. My new VPC. Go ahead and do that, and let's make it really public. How do we make it really public? By giving, by making it go through internet gateway. There you go. We attached internet gateway to that, and we made, so we created a VPC internet gateway to one route table. Private route table has already been created. It's also the main route table. Okay. Main route table is always secured, so that, when I create a new subnet, it doesn't get automatically attached to my public route table. Okay. When I'm attaching a subnet to a public route table, I want to be conscious. That is why I chose that decision. So I created a new public route table, and now let's go to new subnet. So let's create a new subnet. So this is where we were earlier. I'll call it as a public subnet. VPC is this guy. Availability zones 2A, doesn't matter. 10.0.1.0/24. I'll get 256 IPv4 addresses, but out of that, 5 are taken by Amazon, so 251 are available. I'll go ahead and create a private subnet also. And this one, I'll go with 10.0.2.0. Sorry, VPC, right? Step prod. Availability zone, I'm putting in the same availability zone. 10.2.2.2/24. No IPv6. Okay, I got 2 subnets. And one thing I wanted to do is, let's see, guys, I highly recommend you do this one to avoid any unnecessary problems. See here, this is auto assign public IPv4 address. Can I change this one? I want to change my auto assignment. Yes, modify auto assign IP settings. Enable auto assign public IPv4 address, meaning when I create an EC2 instance in my public network, I will automatically get it. Meaning I don't need to select enable, disable in the EC2 setting. It will give me automatically. So every EC2 instance that I create in my public subnet, I want a public IP. Okay?
Can you show one more time, please, Venkat?
Absolutely.
I was on another screen.
Absolutely. So what I will do is, I can actually go ahead and first delete this public subnet. Okay? I'll show you both ways. So I'll go ahead and create a public subnet. 10.0. Oh. Next step, prod, availability zones, and then 10.0.1.0/24. That's very good. So I got this public, right? So by default, take a look at this one. Auto assign public IPv4 address is no for both of them. Hey, by the way, what you can do is, see, this is confusing here, right, guys? Everybody, can you say, I want to show you small filter feature here. See, I have both the VPCs now here. So this is the default VPC, and this is my next step. Oops, there is a typo there. Next step prod. Okay, not a big deal. So what I'll do is I'll filter it. Filter by VPC and 936. Yep, that's it. Now I will only see my my custom VPC resources. Okay, this is my public one, right? I want public IPs to be assigned automatically for any resources that are provisioned in my public subnet. Did you understand what I said?
Yes, yes. Otherwise, we have to mark in EC to IP address enable that.
Exactly. You have to do an additional step. So it makes our life easy. So select this one and then go to actions, modify auto assign IP settings and say enable auto assign public IPv4. We do not want to enable that for our private because we do not need public IPs for our private subnets. Make sense?
Yep.
Okay, now since we created the subnets also, what's the next step? We created the route table. We created route tables. We created subnets. And what's the next step?
We have to attach the route table to the subnet now. So we have to go to public and attach that route table.
Yep, precisely. So let's go to route table, edit route table association. And let's pick up our public guy because this is our public subnet. So public subnet got public and private subnet would have automatically gotten private. Yeah, it automatically got private because my private route table is main route table. That happens to be my main route table. So that's why it's automatically attached it. If you want to explicitly associate it, you can go ahead and do that, but you don't need to. Make sense? Okay, we created a VPC, internet gateway, 2 route tables, 2 subnets. What else do we have to do? That's it. Yes, go ahead.
This is Srinivas. Good morning. Just a quick question in my case here. So the public route table once created, can you change the CIDR range, or you have to delete and recreate? Just
not the route table though. Subnet. There is no CIDR range in the route table. Route table is nothing but it's a logical name for group of rules. That's all. It's a routing rules. That's a routing table. So yes, it's a subnet. So okay, can you change the CIDR range once you create the subnet? No, you have to delete it and recreate it.
Okay. So why I'm asking is my CIDR range is little different between private and public. Hope this is okay, because one has a 10.0.2.0/24, which is available 251 for private.
Yep.
But for public, I used 10.0.0.0/26, so it says available IPv4 R59. Is that okay?
That's absolutely fine. That's absolutely fine. Oh, so what it means is, Srinivas, what it means is, so for your public one, you have 251 IPs, and your private one, you have whatever, 50, how many IPs?
No, it is otherwise. Public has 59.
Sure. Yeah. So public has 59, private has 251. Yeah. So it's not a big deal, right? But when you have to provision your 60th, 60th EC2 instance or 60th resource into your public one, that's when your subnet doesn't have any capacity. Until that point, you're totally fine. And then your IP address is different. That's all. It's instead of having 10.0.1. something, you will have 10.0.0. something. Yes.
Yep. Right? Yep. Thank you.
Not a big deal at all. Okay. What's the next step, guys?
Create EC2 instance.
Exactly. So create EC2 instance. Let's go ahead and create one in private, one in public. Okay. Public one, we want to give, WebDMZ. We want to put it in WebDMZ because that's going to be a web server, and we're going to put a database server in private. Okay, and then we'll explore the internet connectivity to both of them. So let's go to EC2 dashboard. Let's go ahead and create EC2. So launch instance. Okay, so select your network to your custom VPC and subnet. I'm creating the first one as private. I'll create the first one in public, and then see this one here, auto assign public IP, use subnet setting. Subnet setting is enabled. So every every EC2 instance that gets created within the subnet, they'll automatically get public IP. I want that. That's why I selected that. Add storage. Secure name is web server. Security group. Let me see if I have a, nope, it's a brand new VPC, and security groups cannot span multiple VPCs. I want you to understand that. And then subnets cannot span multiple. Can subnet span multiple availability zones?
No.
No. It's an important aspect. So this is a web servers security group, and I'll allow port 22 to anyone. I'll allow HTTP to anywhere. Launch, and then I'll use my brand new key pair. I acknowledge this and launch instance. Okay, my web server is coming up. Let's go ahead and launch another instance. In this time, my custom VPC again subnet is private subnet, and I will not get public IP. I do not need public IP. I don't want public IP because it's a private guy. So add tags, name DB server, security group. I don't have anything. Let me create DB. I'll call this guy as DB server, and then I'll open port 22 to be anyone. But anyway, you cannot log in because you don't go that far. Your front door is closed because you're at the subnet level. Okay. Before it hits the subnet, you're going through the route table, and you don't have any route to that. So you can do it. MySQL, Aurora 3306. Sure. Go ahead and launch my brand new key pair. Launch instances. Yep. So two EC2 instances, one in public subnet, the other one is in private subnet. They both are getting provision right now. My web server has a public IP. Okay. My web server has a public IP, and I'm going to log into my web server and quickly install HTTPD, my Apache web server, because I want to show you something, when we talk about NACL. So that's why we need that. Sudo update -y. Very good. There's nothing to be installed. Okay, please do that. Next is, let's go ahead and start. Okay, service HTTPD start. We need sudo. Very good. And then I'm going to do a vi var html index.html I for insert h1 hello from web server. Hello from web server of public network, public subnet, something like that. Let's go ahead and do that. Well, I'm doing it, fast. I know some of you maybe able to do faster than me. because we need to be able to do it now. At this point, we did probably tens, if not hundreds of times already. So this is my public IP. Let's make sure my web server is good. Very good. Hello from web server of public subnet. Very good. We got it. So everything is good. There's no magic there. We did hundreds of times. And this is our 10.0.1.141 is our public IP. Sorry, private IP. And my DB server's IP is 10.0.2.66. I'll copy that. And then I log into my web server. And why am I logging into web server? Because I want to log into my DB via web server. Okay. So maybe I'll mention something here. It's a new concept here. So you are jumping it. When you are trying to log into DB server, your DB server happens to be in private subnet, and your private subnet is not associated with an internet gateway. So there's no route to internet. Okay, so you will not be able to log into your DB server, but how can I do my administration, my host administration, operating system level patches?
Venkat, a quick question. When you're configuring the EC2 instance for DB server, you give the security routing rules as anywhere also, right? The port?
Yep, but it doesn't matter because your security group you can have one security group for each EC2 instance, okay?
Mm-hmm.
But all of them belong to a subnet, right?
Mm-hmm.
Now your subnet is associated with a route table,
right?
And there is no route itself to the internet. There is no route from from internet into this machine, or there is no route out to the internet from this machine.
Right, but that rule doesn't make any.
Exactly.
Okay.
The rule does not make any sense.
Okay.
That's why when I was giving that, I said that it doesn't matter what you do there.
Yeah, okay.
Because there is no route out to internet and there is no route in from internet. Okay. So that's why I'm logging into web server, and now from web server, I'm going to log into my DB server by pasting my private key there. I'll copy my private key there, and using my private key, I will log into DB server. We did that yesterday. Not a big deal. This is not typical. Okay, so you are actually logging into the web server and then logging into DB server to do the operating system level patches or administration, any general administration to be able to do that, right? So if you use an intermediate server to log into your EC2 instance that is inside the private subnet, that intermediate server is called Bastion host. So Bastion host is nothing but any EC2 instance, okay, that is hardened from all security standpoints, because that has to sit in your DMZ, demilitarized zone, meaning it's in a public subnet. It can potentially take, it's susceptible to all the attacks from internet. Your DDoS attacks or any kind of attacks are possible because it's in the public subnet. It's wide open. Anybody can come on port 80 and then attack it. Your denial of service attacks can happen on that. Okay, so that's why what they do is they'll pick, you'll pick one EC2 instance, you will harden it so much for security attacks so that it can take the security attacks. Okay, and then all it knows is just jump it. It acts as a pretty much a jump box to log into your server or EC2 in a private subnet. That's why it's called jump box also. But it's typically in AWS, they call it Bastion host. Okay, so they will remove all kind of ports. They will remove all the softwares on that. They'll just tighten it. There are some Bastion, AMIs in the marketplace, AWS marketplace. You can use it, but it's nothing. But I want you to know it's nothing but an EC2 instance. There's nothing more, nothing less to that. I can use this as a Bastion host, the one I'm using it right now, my web server. I can use it as a Bastion host. So all I have to do is, but the only thing is, I should not have to use my private key. I don't want to copy my private key there. So they use a concept called the SSH forwarding. So what happens is, so they will forward the SSH. So I will use my private key to log into the web server, and my web server will add my PEM file to the to the certificate hierarchy, and then pass that to the web server. So essentially, without me having to copy the private key, you'll be able to forward it through a SSH forwarding. Okay, that's what is called Bastion host. So anyways, but for now, what I want to do is I used my brand new key pair. So I'll copy this guy. This is my web server, and I'll use a private key .pem file. Insert. Okay, this is my, very good. I got it. And now I want to do a ls minus lrt. I have to do a chmod 400 on this. Okay, so I reduced the privileges on it. Now I can do a ec2-user at my private host, private IP. What's my private IP, guys? DB server 10.0.2.66, 10.0.2.66 minus I private key.pem. I'm logged in. Well, we did all of this yesterday. Make sense? We did all of this yesterday. And this is where we left off yesterday. So is there anyone who is not at this place where we are right now? Is everyone is able to appreciate it? Actually, what we did was...
Thanks for the recap, Venkat.
Yep, you're welcome. So did you catch now?
Oh, yeah.
Wonderful. So sudo yum update. If I try to do an administration on this machine, I'll not be able to do it. I will not be able to do an administration because my sudo yum update will fail because there is no route out to the internet. Okay? So this will fail, and I want you to appreciate this, this fact. And then, no, we just left it. So now, this guy, the DB server, which happens to be in private subnet, cannot talk to internet, and no one from internet can talk to this box. That makes a lot of sense. No one from internet cannot talk to this guy. That makes a lot of sense because everybody has to come through the front door, meaning everybody has to go through the web server, and only web server can talk to database server. Nice architecture, love it. But at least for the operating system level patches, the regular administration, it needs an internet out. You guys agree with that? It needs an internet connection, right? So, but this guy is in, we don't want to attach to internet gateway because that's a two-way traffic now. Once I attach internet gateway, it's susceptible to attacks again. It's like this guy in a public subnet. That is in public subnet. That is the difference between public and private subnets anyway. Association to internet gateway. So I do not want to associate my private subnet to with internet gateway, but I want my private subnet instances to get internet out to do the administration. How can I do that? Well, we talked about two scenarios there. One is called NAT instance. NAT stands for network address translation. So you will create a special device. It's a simple EC2 instance. It will act as a proxy. So this NAT instance will be sitting in a public subnet so that it will have a route out to the internet. So this will act as a proxy, and this will be able to provide internet to your private subnet guys. Okay, so what happens is when you do a sudo m update, things like this, so it will go to NAT instance, and NAT instance will proxy it out. It will do a network address translation as if NAT instance is the one requesting the internet out, and then get the packet and then give the packet to these guys. So NAT instance will be sitting in a public subnet, and you will have a route from your private subnet to your NAT instance. That is how you'll make that possible. So without delay, if it doesn't make sense, don't worry. We'll make it, we'll make it clear right now. So let's go to EC2. The first thing we want to do is, let's go ahead and create a NAT instance. So launch new instance. And here, look for community AMIs. There are a lot of community AMIs already with the specialized software, and that the network level software, this one, network address translation, see this one? And we can use this Amazon AMI, VPC NAT, that we can use the first one itself. So configure, I'll put this one on T2 micro instance details. And where do I want to put it? My NAT instance, I want to put it in my custom VPC. And should I put it in private or public?
Public subnet, obviously.
This guy must always be in public subnet. This will be acting as a proxy for private subnet instances. Private subnet instances will have a route to this one, and this guy will proxy it to the internet gateway and eventually to the internet. Okay? No one can, no one from outside can come and talk to your private subnet instances, but it will get its internet out. So it's a one-way traffic. Add storage, all the default stuff. Go ahead.
So where those AMIs, where did you pick those from?
Community AMI. We can do that together. Do you want me to show you that?
No, I'm good. Thanks.
Community AMI, search for NAT, N-A-T, and then you can pick the first one.
So Venkat, this community API is it implemented by Amazon or some?
No, it's like people like you and I.
So like, how secured are those AMIs? Like, if you want to use in enterprise applications,
yeah, that's a good question. It's how secured are they? Again, it's possible to have some naughtiness here and there. Okay, it's possible. It's up to
because we are, the whole point is we don't want our server to be insecure. We are using, we are implementing.
Yep.
Again, we're going in a different. I mean, this route is again we're allowing threats to be coming in, right?
Yeah, very fair. Very fair. Actually, the NAT instance will have a special piece of software. Okay, and only that will be there. But what if those guys have some, naughtiness or some packet capture or something, something of that sort? Amazon is not responsible for that.
Okay.
It's like Eclipse Marketplace or your Apple App Store, pretty much.
Okay.
So we'll have to look for enterprise grade ones and then go with them.
Even they charge, like, even if you can develop your own image and it can charge for that.
Can you say that again?
So you can they can charge if it is more secure and more protected image.
Exactly.
Yeah.
They'll charge.
Yeah.
So there are some AMIs. Let's say you are building a WordPress website. Okay.
Mm-hmm.
So look for community AMI, search for WordPress, You don't have to do everything that we typically do, like installing Apache, installing MySQL, installing what else, WordPress, and then extract it out and change your permission in www, HTML, all of that. People have done it already. So they created an image, put it out there. There's a company called Bitnami. I think they charge a bit, okay, and then they'll you can use that AMI. They already hardened. That's where they spend time, and then they created an Amazon machine image, and you can go for that.
Okay.
So yes, there are paid AMIs.
Paid AMIs, okay.
Absolutely.
Okay.
If you don't want to do that, we can do it ourselves. This again, NAT is, again, we have to go for the network experts, unfortunately. But once you harden that you can use it. In fact, you don't have to do any of this. I'm showing you one way. I'm showing you previous generation way of, getting things done. I'm going to show you the next generation, which is not current generation, actually, not next generation. I do not want you to use NAT instance at all. Okay. This is also one of the reasons why we don't want to do that. And moreover, NAT instance is a simple EC2 instance. It's not fault tolerant. Okay. If one EC2 instance is down, then pretty much all of your private subnet people will not have internet. So it's not a preferred way. So that's why we must use NAT gateway. NAT gateway is fault tolerant, highly redundant, and then horizontally scalable, gateway. That is what you must use. Okay, configure security group. I'll use my WebDMZ security group for this one because it's going to sit in the DMZ. It's going to sit in the public subnet. Guys, here when you get this boot from general purpose SSD, I'll select this guy, make a general purpose SSD the boot volume for this instance only, not for anyone. And I don't show me this again. Launch, use my brand new keypad. That's it. My NAT instance is getting ready. So once I get the NAT instance, what's the next step? Do I do my DB server, does my VP server get the internet automatically?
No.
Do I have to do anything?
Yeah, we have to go to route table and add this NAT instance. Right?
Beautiful. Yes. So what route table? Do you want to go to the private route table or public route table?
Obviously public route table.
Public route table?
Wait a minute.
Public route table already have the internet
exactly.
gateway.
Public route table has internet gateway attached to it.
Private.
So public route table already has an internet gateway attached to that. They get two-way traffic. Okay, they automatically get it. So instances in private subnet will have a route out to this NAT instance. This NAT instance is in the public subnet. Okay, so let's go change. Our DB server is in this private subnet. So let's go to private subnet. And this private subnet has the corresponding private route table attached to this one. And that one has only the local traffic is allowed. Now let's go to this private route and then look at the routes. Okay, there is only one route. One for IPv4, the other one is for IPv6. Okay, and it's just the local traffic is allowed. So now let's go edit routes. Then everybody must go through my instance. Okay, everybody must go through the NAT instance. Okay. So one tip here, guys. What that one is, go to EC2 instances. If your NAT instance, you have to do two things here. NAT instance must have a public IP. If your NAT instance does not have a public IP, it will not work. So you must have a public IP. And number two, your NAT instance, you have to disable the source destination check. NAT instance, actions, instance, networking, change source destination check. As I mentioned, network address translation is all about checking messing up with the source and destination checks, and adding the source, adding the destination, or checking the source and checking the destination, because it's acting as a proxy, it's acting as a middleman. Okay, I get the packet out. Okay, where do I send this packet to? All I know is I need to send it to, in the entire the table there, it says that, okay, I'll send this packet to next guy, whatever the rule says there. Okay, my source destination. That is required for every single EC2 instance, but that must not be done for your NAT instance, because NAT instance is acting as proxy itself. So please disable that. And these are the two reasons. If at all, even though after you add route to your NAT instance, if things are not working, if there is no internet available for your DB server, then please check two things. One is, does it have a public IP? Number two, did you disable the source destination check? Okay, now let's go. We should automatically get the internet. Let's give it a try.
Need to be on the database server, right?
No, I'm logged into web server. Now I log into database server. Because to log into database server, I have to go through the web server, right?
Correct.
So that we didn't do anything about that process. That process, there is no option. You must always jump through the middleman. You must log into the Bastion host. And in this case, it's a web server. Okay. I'm logged into my web server and then logging into my destination server, which is DB server, because DB server happens to be in private subnet and I can't log in directly. So SSH EC2, there's no doubt there, right? 10.0.2.66 minus I, private key, I'm logged in. Now sudo yum update. Beautiful. See that? Now this guy has internet connection. No package is marked for update though, but this guy has internet connection. So this is how you can get internet connection to your DB server or instances inside your private subnet. Can you guys try that too? Maybe you already did that, but if anyone did not do it, can we do it? Let's do this together. I expect you guys tell me when you're done. I'll pause that video until that point, okay? Okay, can you say that again, Geeta?
So there was a change after creating the NAT instance in DB server routing, right?
So what did you do so far? You created a NAT instance?
Yes.
Okay, very good. And you created a NAT instance. Did you create NAT instance in public subnet?
Yes.
Okay, it makes sense, right?
Yep.
And when you create a NAT instance in public subnet, did you get the public IP? That's
yep.
very important. Did you disable the source destination check?
I did.
Wonderful. Now, so from your NAT perspective, you're all set. Okay.
Yep.
So you have a NAT sitting out there to take the traffic, to take the traffic in. Okay. So your NAT is all set to act as a proxy for your instances sitting in a private subnet.
Mm-hmm.
I'm repeating that. So I want you to tell me what we need to do. Your NAT is all set to start acting as a proxy meaning to start taking the traffic from the instances within private subnet. What do you have to do?
Okay, so in the routing table for the
Exactly.
okay.
So, and see here, the connection is, let me show you that PowerPoint. So the point is, let me show you this so that. Okay, see this one here. So your DB server here, it is trying to connect to it, right?
Mm-hmm.
So your DB server it's trying to get the internet connection through internet gateway eventually, now internet gateway is not attached directly to this subnet. Okay, it's only attached to this guy. So now I must go through the NAT instance. NAT instance is acting as a proxy. So I have to go through NAT instance. Okay, so I have to change my route table. Okay, my route, see here,
Yep.
my private route, I need to change it. By default, it will only have local. Now I need to change it to make it go through the NAT instance.
Okay.
Does it make sense?
Yep.
Yeah. And are you going to change the route table for public route table or private route table?
Private.
Because that is what is attached to your private subnet.
Right.
Make sense?
Yep. Thank you.
Yep. Okay. That's with Geeta.
So Venkat,
Srinivas,
this is Srinivas.
Mm-hmm.
So I'm just little behind. So I corrected the DB server. So then I came back. I'm just installing creating the NAT instance. But all I need to is select the public subnet, right? That's all the important thing.
Exactly. So you selected the community. You went to community AMI, search for NAT, and you found it. Okay. So put that
and then
in your custom VPC and specifically public subnet. That's the most important one. And then when you take the security group, select your web server security group because it's going to be in the WebDMZ.
Just a second. So I'm giving this NAT name and the tag.
Okay.
My NAT. So on the security, what did you say?
The web server security group. Select an existing security group and select the web server security group.
Oh, select the web server. Okay.
Yep. Okay.
There is a VPC security group is there, default. Is that?
No. Did you not create one for web servers?
I'm not seeing those. I only see 4 actually. I only see 4. 3 launch wizard and 1 default.
Okay, I don't know which one you used for that. You can use default, but you will have to add rules. You have to add rules later on. And
traffic, all traffic.
All traffic. No, can you look at? Can you open a different tab and then see what security group is attached to your web server? Did you test your web server first of all?
Yes.
Okay. Yes. So then look at what security group that is associated or attached to your web server. Pick up the same security group for this one also.
Okay. Launch wizard 11 is there.
Sure. Okay. Sure. And that's why I think we should name them properly. Go edit the name.
Okay.
So Venkat, with the public images, how will you determine which one?
You can pick the first one.
No, I mean I'm not asking now, but in general.
Oh, in general, how do I know which one to pick?
Yes.
Yeah, this is like your app store, pretty much. In app store, how do you know which app works? Pretty much, you just have to experiment it. This is like you have no idea, Murali, who these people are, and
Yeah, and we cannot tell what.
Exactly. Some names you can pick up, something like Bitnami is one of them. This is like your marketplace. This is exactly your marketplace. It's not even like.
No. So
Are
it's
you able
at
to
your
do
own risk here.
Exactly.
Venkat, I cannot connect to database server to internet right now. I'm getting timing out.
Okay. So
And
Ketan is not able to connect to. You are not able to connect to database.
yes, I'm getting time out on that.
You're not able to connect from where? 1
I
second.
mean, to internet. I want to go out on internet from database server, and I'm not
1
able
second.
to do that.
Can you share your screen?
Absolutely, Venkat.
Okay. Please share your screen.
I'm doing it right now.
So please use this time, guys. Please use me as much as possible. And
Can you see my screen?
Yes.
Yeah? Okay, so what I did here. This is my net instance, and wait a minute. Come on, look like my internet is slow right now for some reason. But right now it is the public IP there. It is attached with the public IP, and I already networking and change source, which I already took care of it already. It is already disabled, so it can mask now. And also on my, I already routed it correctly as well, but I'm sure where I did it right there. On the route table, this is my private route table. In that, I have added, this is the instance of my net there, and I added that one as well. And for some reason, it is still giving me trouble connecting on the internet right now. And
can you show me that one more time? So
yeah, sure.
I think in the process you did everything right, but in the process you missed the objective. What we are trying to do, I think you missed that. So can we go back to your EC2 instances?
Absolutely, sir.
So what's your objective though? What are we trying to do here? What problem are we solving? What problem are we trying to solve here, Ketan?
I'm trying to connect incoming inbound internet service for my database.
What does it?
It's in private subnet.
So your DB server is in private subnet. Beautiful.
Yep.
That's a correct point. Okay. Now it is in private subnet. Okay. And when it is in private subnet, how can you connect to it? What problem are you trying to solve? Your DB instance, you are trying to do some maintenance to the system, operating system level patches and all. You want to do it. So you need internet connection to that. Okay.
Absolutely.
That is the problem you're trying to solve it. But how can you connect to DB2? You cannot connect to your DB2 from your machine. You have to go through the jump box or bastion host, and your web server is kind of acting as a bastion host here. So you have to log into your web server and then jump another hoop into the database server.
Maybe I missed that. Okay.
So you did everything right, but in the process you missed the objective. So the objective is you log into your DB host. That's not, you log into your DB host and try to, your objective is to do some administering, operating system administering on your DB host, meaning you are trying to do a security patches for your OS. That's what you're trying to do. So you're trying to do sudo yum update. Okay, so you will not be able to connect to a DB host directly, and that's exactly how it should be. You will never be able
have to go through.
Absolutely, you have to go through the bastion host. In this case, it's a web server.
So from the storage, I have to connect and then go to internet. Okay.
Absolutely, absolutely.
I thought now we install that NAT instance and give access to that, so we should be able to use.
Nope, No.
Okay. Okay. Okay,
NAT
got it.
instance will give you internet. It will give you internet to the instances of your, that are in your private subnet. Okay. But you trying to connect to it is a different problem
I got it.
that you will never be able to do it.
And that,
That's exactly
then
how
I
it's
don't need
designed.
then I don't need IPv4 for this, then DB2 at all.
DB2, you don't want public IP. You totally got it.
Absolutely.
Only your
I
web
need
server
that.
need a public IP, and your NAT instance need a public IP because they are in the DMZ. They are in that the front door. They take the attacks from internet. Make sense?
Yep. Because earlier I was trying to do it without that, and that did not work. And I thought, like, I still need IP address because it's going to mask and send it out, and that's the reason I had
Gotcha.
with the IP address,
Gotcha.
but did not work. Okay, I got it. Okay, thank you.
Hey, Venkat.
You're welcome. Yes.
So where do you connect the NAT instance?
Where do you connect to the NAT?
No, where do you add it?
Okay. Did you create your NAT instance first of all?
Yeah.
Did you put it in public subnet?
Correct. Yeah.
Did you get a public IP?
That I did not check. 1 second.
These are the standard questionnaire. Did you get this public IP address?
Venkat, NAT instance should be in public subnet or private subnet?
What do you think?
It should be in private, right?
No.
Public.
No, it is up there.
It must be in public subnet. It must be in public subnet. Okay, it's acting as a proxy out. Okay, so all the people, all the instances from private subnet, they will get internet through NAT instance that's sitting in a public. They go it indirectly. They go to, every packet goes through the NAT instance, and NAT instance will do NATing and then sending out to internet gateway. And then, so there is no route in from internet to your DB server. Okay, there's no way you can go into that. That's what Ketan was just saying, right? But you will be able to get the internet through this hoop, which is NAT instance. So NAT instance must be in public subnet. So Srinivas, no, was it? No, Rego, I think, right? So yeah, do you have a public IP there?
No, I don't think so. No. I'll have to, I think, cancel it.
So if you don't have a public IP, you must have a public IP first of all. I know I'm not answering your question directly. I'm asking some fundamental questions here. So you created NAT instance, you created in public subnet, and you do not have a public IP there. You have to have a public IP. And the next one is, did you disable source destination check? Make sure you do it.
Yeah, I did that.
Okay. So you do not have a public IP, it will not work. Okay. So you have to have a public IP. So if you don't have a public IP, you already created, can anyone tell me how you can get public IP to that? So Regu created a NAT instance and he forgot to check that the public IP.
He need to go to the route table and add it, right?
Okay, he will add it. That's okay. But how can he get a public IP?
So he need to have a public. He need to connect to the public subnet.
I'm talking about public IP. See here, NAT instance does not have a public IP. So how can he get public IP?
There is a check that while creating the instance.
While creating the instance, I agree,
Yeah.
Geeta. But now he already created it.
Oh, there is a checkbox there. There was an edit that you showed today morning.
You can do a manage IP address. You can go to network and manage IP address.
Manage
okay.
IP address, okay.
So you can do a assign.
Oh, okay.
I mean, this is one way. Okay, you can do an assign a new IP. Actually, what you need to do is allocate this elastic IP. What you need is an elastic IP because you need a public IP, right? So go to public IP. Elastic IP address is a static IP address. So if you don't know how to go to EC2 always. and click here, Elastic IPs. Click on Elastic IP and create a brand new one, allocate Elastic IP address, and then pick up one from Amazon's pool of IPv4 addresses, allocate. So now you have an you have a public IP. Now what you have to do is take this take this public IP and then go to actions, associate this Elastic IP to your NAT instance. Does it make sense? This is what you need to do.
But do we need a elastic? Do we need a static only, or we can have dynamic as well, right? If we...
You can have a dynamic also. Yeah, you can have a dynamic also. Yeah.
So we cannot. So what we are doing here, connecting to a static one, but we cannot allocate the dynamic one, right? Or we still can do it.
That's correct. That's correct.
Just the static only. Okay.
Yep.
Thank you.
So do that, Raghu, and then I know I still did not answer your question. So after doing all of that, then go to your private route table. Private route table, and now add a route to your NAT instance. Essentially, you're flowing the traffic through the NAT instance. That's what you're doing. So let me do a small check here to see how you guys are doing it. Let me quickly pause. Okay, tell me again now, Srinivas.
So I created a NAT instance.
Mm-hmm.
Now you said I need to assign the NAT instance to a private subnet, right?
Now you have a NAT. Let me ask these questions again. You created a NAT instance. Okay. You created that in a public subnet.
Yes.
You have a public IP for your NAT instance.
Yes.
You disable the source destination check.
Yes, sir.
So all 4 steps are done. Very good. Now you have to enter a route from your private subnet to the NAT instance. So what you have to do is go to the route tables. Go to, this is an answer to your question also, Rego. Go to your VPC, go to your route tables, select your private route. Okay, because this private route or private route table, this is what is attached to your private subnet. And what is your objective? EC2 instances sitting in private subnet, they need internet access. So this private route table is the one that drives the rules for your private subnet. So go to routes, and then by default, you should have only one or, one for IPv4, one for IPv6. So you only have local traffic. Now you don't have this third route. Now you create a new route saying o.o. meaning everybody, and then click here, NAT or instance here. Click on instance, and then it will show you all EC2 instance. It doesn't know which one is acting as a NAT instance. So you select your NAT instance here, and then save route. That's it. Make sense?
So next is I just need to verify.
You just need to verify.
Connecting.
Yep. So log into your web server and then log into DB server through your web server, and then do a sudo yum update and see if you're able to get the internet. So you're able to do administration. Okay, you're good. Kiran, are you good?
Yeah, Venkat.
I will not ask individually, rather you guys tell me. I'm starting here in alphabetical. Kiran, Geeta, Karuna.
Yeah, Venkat.
I'm good, Venkat, actually. So I'm able to connect to DB server.
Wonderful, wonderful.
Yeah, did updates.
Yeah, I'm good, Venkat. I'm able to connect.
Wonderful, wonderful.
Venkat, can we take a break? I need to step out for a few minutes, or I can wait some more time.
Yeah, another 15 minutes because it's going to be, actually it may take 30 minutes or so. Let's see, Murali, because I want to, we'll take a logical, I don't know if you need a break. But we'll
Venkat, one quick
Yes.
question. Can you please show me how to disable that? After creating the instance, you need to disable, right?
Oh, yes. Disable source destination check.
Source destination.
Sure.
Because I recreated the image and
Sure.
after that, I am not sure if I did that.
So click on NAT instance, actions, networking,
Okay.
change
Okay.
source destination check. And
Okay.
then, okay.
Okay.
So at this point, I'm assuming everybody is okay.
Yeah, Venkat, this is Karuna. I just started with creating VPC and public subnet and private subnet too. So I'm just little behind, but I'm doing okay.
Wonderful.
Whenever I have a doubt, I'm just following the documentation
Very
too.
good.
So I'm good with that. Thank you.
Very good.
Hey Venkat, this is Ravi here. So
Ravi,
I mean, yeah, even I was a little bit behind because I was going through all your created VPC and stuff again. So I may have additional questions, but I'll contact you or send you a message separately.
Sounds good.
I'm good, Venkat.
Okay. So let's, I'm assuming at this point, everyone is good. If not, this is the time. Okay.
I'm good, Venkat. So this is
very good. Very good. So guys, now we did one way, right? Which is NAT instance. I told you NAT instance is not the right solution for achieving this goal. What is our goal? Goal is our instances in private subnet needs an internet connection without having a route out to internet gateway. Meaning, I don't want to put them in public subnet. Okay, they have to be in private subnet. They are in a private subnet for a reason, but they need internet connection so that they can administer. So we did that through NAT instance. NAT instance is a single EC2 instance, and if you have hundreds of instances in your private subnet, all of them are getting internet through that single EC2 instance, which is NAT instance, not preferred. Well, because the reason it's not preferred is because there is no fault tolerance there. Well, you can make it fault tolerant by providing it, by putting them behind auto scaling group, and you can have them grow, and you can write the rules around it like any other EC2 instance. We can do it, but it's troublesome. We will be managing it. Rather, Amazon has provided a slicker way of doing it, which is through NAT gateway. This NAT gateway, go to your VPC. It's exact same thing. Click on VPC. It's very simple. Click on VPCs and NAT gateway. See here, NAT gateway. So we don't have any NAT gateways. So create a NAT gateway and put this guy in public subnet. Like how you are putting NAT instance in public subnet, your NAT gateway also, it must be in public subnet. So it must be in next step prod and then public subnet. And then it needs a elastic IP, meaning it needs a public IP. So allocate an elastic IP to this guy. And then I'll create, I'll call this as a NAT gateway. Okay. So NAT gateway, that's all. You created NAT gateway now. So this is not an EC2 instance, but rather it is a highly available, fault tolerant, highly scalable gateway. Meaning it's acting as a true gateway. It knows how to do, it knows how to route the traffic to internet. Okay. So you are not relying on community AMIs to achieve your goal. Okay. Amazon is giving you this gateway, and Amazon will automatically scale as needed. If you need more bandwidth, if behind the scenes, if the EC2s these instances are not enough, it will automatically add. In fact, you will not have access to any of them. It's a provision service. It's pretty much, you don't have to worry about it.
Is this an additional paid service kind of thing?
Of course, it's a paid service, yes.
Okay.
They will give you bandwidth all the way until 10 gig, I think, 10 Gbps. It's a NAT gateway is a really powerful way to solve your problem. It's a scalable approach. It's fault tolerant. But one thing, both with NAT gateways and NAT instances, though, one thing, it's a food for thought, guys. Everybody, I want to have your attention for a second here. Let's say I have 3 availability zones. In each availability zone, I have a public and private subnets. Okay. So my subnet cannot span availability zone. My subnet can be only in one availability zone. I want to reiterate that fact. Okay. Then I have private instances, my availability zone 2A, 2B, 2C, in all these 3 of them. They all need internet connection. Then obviously they all need NAT gateways. So you have to have NAT gateways in the public subnet. And you have to have, since that subnet cannot span multiple availability zones, you have to have them in each availability zone. I just want to mention it out there. If it doesn't make sense, I will repeat it. Either NAT instances or NAT gateways, you are putting them in public subnet. Okay, the objective is instances in your private subnet need internet connection. You want to proxy them through either NAT instance or NAT gateway. But these subnets cannot span availability zones. So if you created a public subnet in 2A availability zone, it's good for routing the traffic for the private subnets within that. But you have to go through you have 2 more availability zones, right? So you need NAT instances or NAT gateways. If you want that highly available system, available application, then you need your NAT gateways across all the availability zones. I just want to mention that. So you got your NAT gateway, okay? So now go to edit route tables, or you can close it, come back to route tables here and go to your private route. It's exactly same thing. It doesn't matter whether it's a NAT instance or NAT gateway. NAT instance is just one instance. You're relying on one instance. Okay, if that one instance is down, you don't get internet connection for your, private instances, private subnet guys, right? So go to routes and then edit routes. This is through NAT instance, close it. I'll just add a new route here. And this time I will select here NAT gateway and I'll give this ENI, that instance. That's it. My NAT gateway is attached to this private route. Now, instances in my private subnet will have internet connection through NAT gateway, which I do not have to manage. It's a managed service, Amazon managed service, which I will not have to worry about it. It's a redundant, fault tolerant, highly available, it's auto scale. I want that. Okay, it's reliable. I'm not relying on a single EC2 instance. And now I can go and terminate my NAT instance. Make sense, guys? And how do I test it? Well, same testing. Make sure your DB server is getting internet connection. Sudo yum update. You shouldn't see any difference. It doesn't matter whether you're going through NAT instance or NAT gateway. Does it make sense?
So now, Venkat, okay, so we can directly go to our DB server and then get the internet connection, or do we need to go again through the web server?
we are talking about two different things here. You know, Kiran, you being able to connect to DB server is one thing, meaning you want to go into the DB server. You want to be able to connect from outside. That is problem number one. That one, there is no solution. You have to go through your intermediate web server or intermediate bastion host. There is no way out of it, because that is by design. We designed it that way. We wanted it to be that way. Does it make sense?
Yeah.
We wanted it to be that way because there should not be any internet traffic from outside. No one outside of my VPC can talk to me, period.
Okay. Even though you had a NAT gate or something, it will never allow.
No, that's a different problem. Okay. And that's not a problem. That's a good thing. That's by design. It's working by design. We do not want any internet traffic to reach me. My instance is in private subnet. Nobody will reach me. Everybody will have to reach me only through the public subnet.
Okay.
And the public subnet guys are on the front line, meaning they are in DMZ. They can take the attacks, and I know we harden them, but they are typically web servers or the bastion host. I will log in there, and then I'll hop into my DB servers or the backend servers. Does it make sense? That's a problem number one. So we should not get confused with both of them.
Yeah.
Kiran, the first one is the first one clear?
Yeah, basically the design itself is like we should never allow the internet to...
From internet into the box. Now, that problem is, that design is different from this DB server. I have to be able to do administration, host level administration or OS level administration. For that, I need internet connection to this. My DB server needs internet connection is different from I want to connect to my DB server from elsewhere. They're two different things. You cannot connect to your DB server directly, period. You must go through your bastion host or the, one of the hops. Does it make sense?
The IP itself is secured. I mean,
what's that?
The DB server IP itself is too secure that you can never.
It's not the IP that's secured, but it's inside the subnet.
Yes.
It's in a private subnet.
Yeah.
Okay. It's in a private subnet, and there is no route out. Okay. There is no route. There is no direct route to that. Okay. Because all the outside traffic has to come from where? Internet gateway. All the outside traffic must come through the internet gateway. And then only it will distribute. Your router will distribute to the appropriate appliances. Whether you're going to application load balancer or EC2 or some other, but your front gate is internet gateway. And there is no route to the internet gateway, period. So outside guy cannot come into my private subnet, period. There should not be any confusion. But it doesn't mean that my private subnet guys cannot go out to internet. No, they need to be able to go out to internet. Why? To administer my operating system, security patches, and then I want to install MySQL, and I want to install my, patch them regularly. And I want to install my minor versions, major versions. For all of that, I need internet. I need to go out. I don't want anyone outside to come in, but I need to be able to go out securely. Not through internet gateway though. How? Through NAT instance or NAT gateway. NAT instance is not a preferred way of going out. So that's why I want to use NAT gateway. Am I making it clear, guys? Any questions?
Yeah. Sorry, go ahead.
Venkat, can you share that last slide of your PowerPoint presentation? And I'm still wondering,
Mhm.
say from private network, we go to router, and from router, there is the arrow going to NAT gateway, right? That means from private, I should able to connect to NAT gateway without going through web server, right? Or I still have to go through web server.
No, we are talking two different routes here, right? See here, from DB server, I need internet.
Yes.
That is use case number 2.
Agree.
Guys, this one, Ketan here, my DB server needs internet connection. I need to be able to go out is use case number 2.
That is correct. And that is what I'm talking about.
You sitting here, I need to be able to go in is the use case number 1. You cannot go in. You
No.
must
Yeah, no, why that not? I got that point. We don't want to come in there. Obviously, only one way is through the internet gateway. Is the one only entry point there for the public network.
Yep.
I want to go out from my private network.
Yep.
And the way we saw that is we have to log into web server, and from web server we go out for our database server updates or management of our database server.
You're mixing both. You're mixing both. That's where I'm. Yeah. So one second. Sorry.
Yeah. Go ahead.
From outside, you are logging into database server is one use case. Okay. So you go to web server. From web server, you log into database server. First, let's talk about that.
Okay.
Are we clear with that?
Yes.
Okay. So you cannot log into database server, and there is no NAT gateway, nothing in the picture at this point. You're logged into web server because your web server can talk to database server, because they are in the same VPC, you are able to log into database server via web server.
Agree.
Are we on the same page now?
Yep.
So the use case 1 is good.
Yep.
Okay. Now database server needs internet to update, its operating system level patches.
Yes.
So it needs internet. Everybody needs everybody can communicate to the internet only through internet gateway.
Yes.
Since internet gateway is not attached to my private subnet, okay, what I'm doing is I'm putting a proxy in the form of NAT gateway here in public subnet. When I try to go out, the way I change my route table is that anyone except private, anyone except my local guys, right? You have to go through NAT gateway. That's what my route says. My route table says. Correct? This is my rule. So when I try to do a sudo yum update, it goes to router. Router will say that, oh, you are trying to go out to internet. Okay, let me see. Let me look at my rules, guys. Okay. So it will look at like menu and then say, okay, you are trying to go to internet. Okay. Are you trying to go here? No, you're trying to go out to internet. Okay. Then let me, my rule says that I need to send this to NAT gateway, and I'll send it to NAT gateway. NAT gateway will kind of mask it, okay, or NAT it, network address translate it. Okay. It will do some massaging to your packet and then say that, and then send it to the router again and send it to the internet. So NAT gateway is now sending the packet out on behalf of you to internet gateway. Am I making sense?
Yeah, you do. And what I'm wondering here is then when we had to go to, when I was working on that and you asked me to log in through web server only on database connection, that is what I confused with it. Like I mean on the update one on the internet connection on my database server, right? So when I had to get the internet connection, incoming internet connection for my database server, I mean not incoming. Let's say I would update on my database server. The second case that you are talking about.
Exactly.
Right. In that case, we don't have to go through web server, right? We can, or we still have to go through web server only on
there is no web server is not in the picture at that point. Okay, you are logged in here. One way or the other, you are logged in here. Once you are logged in, everything else is everything else is is not in the picture. So you are already logged in here somehow. What is that somehow? Through the web server, you logged in here, right? Now the only use case here is that I need internet connection.
Yes.
Okay. At this point, when you do a sudo yum update, it goes to your router, and your router will check this checklist and then say, oh, okay, so you're trying to go out. Let me give this request to NAT gateway. I'll give this to NAT gateway. NAT gateway will kind of massage it. Okay. They call it NAT, network address translation. So it will do a massage it and then give it back to the router. And now since it came back from the NAT gateway, now it will pass it to the internet gateway, to let's say google.com or something like that. And it gets the packet out, and then NAT gateway again re-NAT it, meaning it will reverse it back to, okay, now send this to database server, that packet, and then it send it to it.
Agree. So only thing, now I got it. I think. Sorry for the confusion. So now I got it. So in order for us just to log into database server, we go through the web server, log into the database server, and from database server we go out to internet for update. That's what it is. And when we go out for internet for update, again we go through the NAT gateway again. Okay, thank you. I got it. Yep, I got it. Thank you.
No worries. And I want to tell you something though. These are pretty. The whole VPC concept is very important, but it's very tricky though. It's tricky, and I must tell you how how great you guys are doing. Yeah, you guys are doing phenomenal. First time when all of this, trying to wrap my head around it, I was like genuinely blown away. I took my time. I genuinely took my time, a lot of time, to really understand it. Like, a lot of whiteboarding, research, reading, and fundamentals. Yeah. In all fairness, I'm not a computer science guy too. But that's
for us.
Beauty.
But
yes.
For us, you have done all your research, Venkat. That makes a lot of difference, right? If we have to go ourselves, all these things, it's not going to be easy. I have gone through this many times, so I'm saying that it's not easy.
Yeah, it's pretty tough, but it's a very important piece though. Not only from the certification point of view, from your interviews point of view, from your real world point of view, your viewpoint will change when you go back to office tomorrow, right? Your viewpoint, your perspective will change when you start talking to the networking people. You will start to make sense what they're saying. You'll be able to understand it. You will be able to converse better with them, your network architects and all. And being a solution architect, you have to be, jack of all trades. So you don't have to be expert in pretty much, you can't be expert in any area being a solution architect, but you have to be able to converse with anyone. With the DBAs, when it comes to database administration, you have to be able to talk to network architects when it comes to network activity, and you have to be able to talk to security architects. They're all specialized people. You sitting in the middle, you have to be able to converse with anyone. Okay, but you have the breadth, you don't have the depth. That's the only difference. Okay. Oh, that's why there is a certification in AWS called network specialty. If I may be phrasing it wrong, but there's something related to the network specialty, and that's highly respected certification also out there. Okay.
Yeah,
that's a network specialty, and there's a security specialty. There is a machine learning, I believe, and there is a big data related certification. Yes, is that Kalyan?
Yeah, I have a small question. Can you please go to the subnets?
Absolutely.
Yeah, open any subnet like public or private.
Sure.
So go to the route table.
Mhm.
See here, we are seeing 3 targets, right? Like second one is internet gateway and some numbers are there. So I see if there are 10 internet gateways already created for different purposes. By seeing the subnet, I wanna see custom names instead of going what it is exactly, like 0654 what it is, instead of like a given
Right.
name. By seeing that one, can I is I mean I don't want to go to the internet gateways, how many are there. By seeing that one, I wanna know, okay, this is meant for this one. Is there any way like logical name to give here?
Unfortunately, not in the console. Not in the management console. This is how he's giving it, Amazon management console, but this is only one way. You can use your CLI to view it, or you can use your SDK. If you're a Java guy, you have a Java SDK.
Okay.
Seriously, you have a Java SDK for all of this one. Trust me. And you have a Java SDK is only one of the SDKs. You know, you have .NET SDK and others, right? So you can write your own front end. This is what he gave you.
Okay.
Okay. For your own purposes, if you happen to do it, you can write your wrappers. You have to build it. Or if you're dealing with your SDK, you can do it at the SDK level. But unfortunately, here there is no option, Kalyan. I know it's in some cases he did pretty good job.
So
the route tables, right? 1 second here.
Yeah.
So the route tables, right?
Yeah.
So route tables in the public route, when I look at the routes here though, I know. So see what you do is this, he did pretty good job here. If you look at the internet gateway here, right? See here, he's providing the description here.
Okay.
Okay. Here, he's providing the description here. Next step prod IGW.
Okay.
But once I select it, save the route, now when you go to the subnet association, no, it's unfortunately no.
And one more thing, can I use this public route table for multiple internet gateways?
Let's talk about it. So can I use this public route table for multiple internet gateways?
Can I? Yes. I mean, I created 10 internet gateways. Can I configure those 10 for this?
1 second.
I mean, just
yeah. No, I understand your theoretical, theoretical question, right?
Yeah.
So, but let's attack it a little more logically. I don't even come to practical purposes, but let's attack it. You can assign only one internet gateway to your VPC, period.
Oh,
I don't even have to answer your rest of the question.
Yeah, I got it. I got it.
Okay. So that's one of the important aspects even in your exam. There can only be one internet gateway per VPC. So that's why when you select your internet gateway here, see here, this is the default internet gateway. When you created your account, it created a default VPC, right? Along with the default VPC, it created an internet gateway here. So once you try to associate it, see, you can only detach it here. Once I detach it, okay, once it is detached, right? Now, if I want to attach to VPC, it's only showing me default. It's not showing me the other one because the other one already has association.
Yeah, got it. Yeah.
So you cannot have multiple internet gateways, and these internet gateways are highly, redundant, fault tolerant, highly scalable. They can take 10 Gbps. They can automatically scale. They can take huge throughput. Okay.
So like Venkat, so we have VPC, I mean in VPC we can have subnets in different availability zones, right? So, and then will all the availability zones are managed through this only one internet gateway?
You got it.
Okay.
So one VPC will have one internet gateway. Doesn't matter how many subnets you have it within that. Because your internet gateway is not one simple EC2 instance where traffic is going through. It's not. Imagine your home router itself is pretty. It's a network appliance, right? It can handle decent throughput, right? So this internet gateway is several of those appliances. Okay, and then this internet gateway is acting as a gateway for all of them. So that's attached to your VPC. So you can only have one internet gateway to your VPC.
Okay, one more question. Actually, when you go back to the diagram, like AWS, this diagram, so here in this case, we have the database inside this VPC, right? So can we talk about in general case, sometimes like the database instances are outside the VPC, and then our the services, the Tomcat servers are, they try to connect to the databases, right?
Okay.
How can we give, is it through, how can we give access, from this web server, servers sitting in the public subnet to the database connectivity? Like they are in outside the VPC. So
no, they are not outside the VPC, period. First of all, let's get to that, right? So everyone is in the VPC. They're not outside the VPC.
Here everyone is inside the VPC, but
no, I'm saying any company. I'm saying any internet scale company. Okay, VPC is having your own data center, right? In your company right now, you have your database server sitting in the VPC. It's having your own data center. You have within this VPC. Even in the case of AWS, you have 65,000 servers within this VPC, and your database server is one of them. It is not.
Okay.
Go ahead.
Actually, in some cases, we will deploy some services to VPC, right? Cloud, and some are not actually. So in that case, but the database is same for the instances, JBoss instances, or like the web server, the web servers sitting in the VPC in the cloud.
Right. Okay. You are mixing then 2-3 different concepts. But let me answer your question first before getting to your specific problem. Okay. So first of all, I want you to understand that for all not practical purposes, even in the theoretical purposes. Okay. So your database servers are sitting inside this one too. So first I want you to understand that. So they're not outside the VPC. Okay, they can be in their own VPC, but that's extreme cases. But what you are bringing up is specialized use case. So what you are doing is that there is something called, there are a couple of ways. One of them is called AWS Direct Connect. I don't know if it's logical time to do it right now, but let me do it. Let me try it. Okay. So the scenario that we are talking about here is that the one Uma brought up, this is for everybody, okay, is part of our resources in their use case, part of our resources are in the cloud, but part of our resources are on-prem. Okay, so they have their own on-prem, but part of them they moved it to AWS cloud, and they have a VPC here, all of your EC2 instances and everything. So how can I connect to this? So some servers, in their case, all the database servers, they did not move it for their own reasons. There could be legal reasons, security reasons, and auditing reasons. They could be probably they're responsible for reporting to White House, the financial institutions, right? So, but they put all of their web servers and other application servers, everything here, but they put their database servers within this. So they are not part of that VPC. So what they do is there are a couple of options there. How can they talk to each other? So there are a couple of options there. One is through, as we know, VPN. So site-to-site VPN is one of the options. So you'll establish a VPN between these two guys, okay? But that VPN, pretty much it goes through the VPN tunnel, okay? It's encrypted, okay? But the packets go on a regular public internet. Those encrypted packets go on a regular public internet. That's one option. So site-to-site VPN, you'll establish a site-to-site VPN, and then you will be able to communicate as if you are in the same network, even though these guys are on a VPC and these guys are not. But you'll be able to communicate as if you are in the same VPC. Okay, that's a site-to-site VPN. The other one is called AWS Direct Connect. Using AWS Direct Connect, what you do is you will establish a physical connection, the direct connection from your corporate data center into AWS data center. Okay, and you will run your own leased line. Okay, and then you put your appliances, you keep your appliances somewhere in between the gateway, in some physical location. You put your appliance here, and then AWS will keep their appliances there. And then here, there is no public internet in the picture, but you will use Amazon's backbone internet. So it will only go through Amazon. So all of this one, once it reaches their Amazon gateway, okay, it will only use your, Amazon's private internet connection. They call it Amazon's backbone internet. Okay, so it will not go to the public. You're pretty much having a physical, direct connect between your corporate data center and into Amazon. So big companies, even like your companies like your company, MasterCard, Bank of America, all of them, the big companies will typically, if they want to go cloud, they will have a direct connect established. It's pretty complicated architecture, at the network level, deep network level. And then it's not just a software. You have to have a physical routing involved and physical infrastructure involved at the network level. So they will have this AWS Direct Connect. Okay, this is not for any medium-sized company. This is like for big financial enterprises, etc. So you will get enormous throughput, highly available, and you are not going through the regular public internet. You are going through your dedicated network appliances. So you have a site-to-site VPN and you have a AWS Direct Connect. Now there is another option. This is called.
So one quick question here,
Sure.
Venkat, before you move on.
Okay. Yeah.
So is that AWS Direct Connect and AWS Gateway, S3 Gateway, are kind of similar, or it's entirely different? Because
they are different.
Okay.
They are different. So I did not mention about S3 Gateway or VPC endpoints yet, right? So they're different actually. So hold your thought on that, Ravi. I'll get to that. But did you understand what AWS Direct Connect is? And did you understand what a site-to-site VPN is?
Oh yeah, definitely.
So
I know.
Yeah, I know you're working on it. So you understand how your corporate side of it gets connected to your VPC and any other appliances. Okay.
Yeah.
So before I talk about VPC peering, though, Uma, did you understand so far? And this is not just for Uma. She happens to have asked that question, but I wanted to, you will pick up 1 or 2 points in the exam if we understand this.
Yes, Venkat. So I'm just following it.
You understood?
Yeah.
Okay.
To come back to her question, right? I think the more her, I mean, what the assumption is, between if a web server is on DMZ and database server is on private network, something like that, Venkat.
Yes. So okay, let me rephrase her question, right? So their scenario, this is their customer network, right? They have their databases in the customer network, but they have their application and web servers sitting in a VPC inside the cloud. This is exactly what it is. Did I capture the problem statement right, Uma?
Yes, yes, Venkat. Yeah.
So you have your database servers in your customer network, and you have, they extended it. They call it, this is a hybrid environment. This is like a hybrid cloud. So they left their database servers within their customer network, but they moved on everything else to the VPC because they want to take advantage of it. And 9 out of 10 times, for since I know your financial institution, right? So you will have a direct connect, and pretty much, but direct connect is a very expensive solution, and but it's good for if you don't want to go through the regular internet. Okay, if you want to go through the dedicated private virtual interface, this is the best way to go about it. Pretty much at that point, right? Once you establish the direct connect or VPN, either of those two solutions here, the beauty is that when you log into this, you will be able to ping it. You will be able to talk to this database like you are in a same VPC. That is the beauty. Okay, so you have your site-to-site VPN is one option. You have your direct connect is another option. Let me, since we're talking about this topic anyway, let me introduce this concept called VPC peering. So it's not directly related to, we talked about Uma's specific problem. Half of the resources are in customer network, their network, their company network, and another half in the cloud. Okay, we talked about that. So let's say I have a VPC. I have one VPC in one account. I have another VPC in another account. Or I have two different VPCs within the same account. Or I have one VPC in Asia Pacific region and another VPC in Northern Virginia region. Okay, both of them. So will they be able to communicate it? Is the point. Yes, you can do that using a virtual appliances, virtual VPC component called VPC peering. A VPC peering connection is a networking connection between two VPCs that enable you to route traffic between them using private IPv4 addresses or IPv6 addresses. Instances in either VPC can communicate with each other as if they are within the same network. This is exact same statement is applicable for you, Uma, for your question also. The exact same behavior happens when you do the direct connect also. You can create a VPC peering connection between your own VPCs or with a VPC in another AWS account. The VPCs can be in different regions, also called inter-region VPC peering connection. Okay. So let's say this is Bank of America, and Bank of America is dealing with close vendor, and vendor, they're so tightly coupled. Okay, they wanted to vendor is in a different VPC, and these guys are in a different VPC, and they wanted to have a VPC peering. Okay, you can have a VPC peering, and pretty much once I'm logged in here, I'll be able to see all these resources also as if we are on the same VPC, as if we are on the same network. There is only one catch here. The catch is your private IPs cannot have conflicts. Meaning, if I take 10.0.0.0, and if this guy also take 10.0.0.0, I cannot do a VPC peering. If there is a conflict in my private IP ranges, then VPC peering will not be successful. See this guy? This guy has used a different private IPs, 172.31.08, and I have used 10.0.0.4. So you will be able to establish a VPC peering. So there is another important concept, especially from certification perspective. There is a concept called transitive VPC peering. In fact, transitive VPC peering is not allowed is the concept. Okay, what it means is VPC A has connectivity to VPC B. Let's say VPC B has connectivity to VPC C, then you may be thinking that through B, maybe VPC A has direct connectivity to VPC C. No, that transitive VPC peering is not allowed. You have to have a direct peering. So VPC A has peering to B, and if you want connectivity through VPC C, then VPC A has to have a direct, VPC peering with VPC C. So just because A talks to B and B talks to C, so A can talk to C. No, that does not work. So that's called VPC peering. And understand this one line alone, you will get typically get at least one point you'll pick up, either directly or indirectly, because he'll give you a scenario there, and then it helps you with the elimination. So he will say that, yeah, because I have a transitive, VPC A talks to B. Since B talks to C, A can talk to C. So through transitive peering, I'll be able to do that somewhere in the answers. So transitive VPC peering is not allowed. Okay, so that's about VPC peering and go ahead.
So,
absolutely, go ahead.
If you open up that, yeah. So here you saw like an instance VPC A, VPC B, and there you talk about that IP address, right? Mm-hmm. You mean it's a CIDR range we are talking about, right? Not
absolutely. Yeah, I'm talking about the CIDR range.
Okay, because we said 32 and then I'm like, oh, but it's an instance you are saying, okay, got it.
Yep. Someone else was asking something.
What is the advantage of doing this VPC peering?
The advantage of the VPC peering, well, so if I'm partnering with this one, pretty much now I will have access to the complete all these instances, right? See, I don't have any control over this VPC. I don't have any control over this VPC, okay? And I'm in this VPC. So let's say I have two companies, they merged. Let's say, that this is our company, we acquired this company. So I have two options there, right? Bring them into one single network or open a VPC peering, pretty much. A lot of acquisitions, after acquisition, they do it typically this way. And especially this inter-region VPC peering, right? If I have, one in Asia Pacific, somewhere in Singapore, and the other one in here in the US East. Okay, I'll be able to connect to these instances directly from my VPC. Okay, so I can only, this is where I will administer, I will maintain. This is my VPC. This is where my web servers are. This is where my database servers are and everything, right? So from this one, I'm able to connect to this VPC as if in the same IP range. So just now we are able to log into web server, and from web server we were able to connect to a database server, right? They both have the private IP addresses. So I can log into a web server here, and I can, from there I can go in, talk to any of this. I can log into these guys and I can administer them without having to do anything. I don't have to do pretty much anything. And I can use my file sharing for the inter-region. Pretty much all of them, imagine this as a big VPC with everybody. But if imagine one big VPC, you can only have a one IP cider range, right? If I start with 10.0.0, that's what it is. But here I'm able to log in and administer all these instances in the VPCB also. So if you deal with, very tightly coupled vendors, and if you want to expose all of your resources to them, if you want to administer their resources, and if you want to let them administer your resources, then VPC peering is one of them. Typically, as I said, your QA will have its own VPC and your prod will have its own VPC, and you can have VPC peering between them and put some rules around that. Or as I said, acquisitions. Acquisitions is where we have used it. When we acquired somebody, we created a VPC peering. Okay.
Venkat, what kind of internet do we use? Do we use public internet or is Amazon internet connection here while we are doing VPC peering?
So VPC peering, so once you go out of this one, right? Once you create the peering, it goes to the public internet only. It goes to the public internet only.
Okay.
You have to have a direct connect. This is like your VPC only, because it's this is like your site-to-site VPN only. So it goes to the public internet, but it's in an encrypted form. Your VPN, every packet goes to the public internet, but through encryption. Only direct connection, direct connect will go, through the dedicated network.
Okay.
Venkat?
Yes.
This is Raghu. So I think this is a basic question. I think so. Yesterday, when you had given us those instructions, so you did not tell us to create a private route table, and today you said that we have to create it so that we can use a NAT instance and NAT gateway. Correct?
Okay. Private route table, I just renamed it. Yesterday I called it main route table. Main route table and private route table, they are same.
Okay.
Okay. So main route table is the one that gets created when VPC is
by
created.
default. Yeah.
By default.
Yeah.
Okay.
Yeah.
And I want my main route table to be private route table. Why?
Okay.
Because when I create a subnet, my main route table is what gets associated to my subnet automatically. Does it make sense?
Yeah.
Okay. So that's why I want to keep it as restricted as possible. I want to keep that guy as restricted as possible. Okay. It's about VPC peering. This is AWS Direct Connect is a cloud service solution that makes it easy to establish a dedicated network connection from your premises to AWS. Using AWS Direct Connect, you can establish private connectivity between AWS and your data center, office, or co-location environment, which in many cases can reduce your network cost, increase bandwidth throughput, and provide a more consistent network experience than internet-based connections. Internet-based connection, when he means internet-based connections, he means site-to-site VPN. But it's an expensive option too, not for everybody. Okay, VPC endpoint is one concept I am left with, and then we are done with VPC. Pretty much I wanted to say the hardest topic in all fairness, and also I can tell you safely, maybe it covers 15% in your exam. I mean, good 10 questions, easily 5 to 10 questions. You have to be able to do this complete VPC from memory to really pass the exam. So VPC endpoint is another concept. I don't know if you guys can take it. Maybe I can wrap this in 5 minutes. You guys have another 5-10 minutes?
Yeah,
so
I'm good. Thanks.
Okay, you know what? Let's finish it up. And especially we talked about site-to-site VPN and VPC peering and direct connect. and endpoint. Somebody mentioned this question. Ravi asked this question. Endpoint. So you got that AWS Direct Connect, okay? And you have that site-to-site VPN. Site-to-site VPN goes through the public internet in the encrypted format. They call it VPN tunnel. They go through tunnel. Okay, so let's talk about VPC endpoint. And it's very relevant right now because we have public subnet and we have private subnet, and we have instances in private subnet. So we have instances in private subnet. Nobody can talk to private subnet. I can't even log into my private subnet instances. I have to go through my public subnet, my Bastion host or web server. Okay, I have to go through that. So, but I need internet connection. We talked about why and how we can get it. One option is to get the NAT instance. The another option is to get the to go through NAT gateway. We got that, very fair. So the VPC endpoint is different. So with VPC endpoint, let's say I don't need a generic internet connection, but I need to be able to communicate with my S3 bucket. I want to be able to write to my S3 bucket, or I want to be able to read from my S3 bucket. Well, I understand S3 bucket is in public internet. Well, you can use your SDK, you can CLI, or you can REST, or you can go to your Amazon Management Console, etc. So your S3 bucket is in the public internet. So one way to get it is definitely through NAT instance or NAT gateway. Understand it here. My DB server wants to talk to my S3 bucket. Okay? My DB server, which happens to be inside a private subnet, it needs to talk to S3 bucket, and it wants to download some files from S3 bucket or upload some files to S3 bucket. Well, one option is it's in the internet. So like anything else, like how my DB server wants to go, talk to Google. Similarly, I can also go talk to this S3 bucket via my NAT instance and NAT gateway. That's one way to skin the cat. The another one is without needing your NAT instance, NAT gateway, VPN, direct connect, any of these solutions, as long as your services are some of the AWS services. AWS only supports certain services like something like S3, okay, or something like DynamoDB. It supports DynamoDB as a gateway endpoint, or it can support S3 also as a gateway endpoint. But these two services, if I want something, okay, then you don't have to go to the public internet. You will never go to the public internet. Your packet will not leave AWS data centers. Without your network packet leaving the AWS data centers, you will be able to go connect to your S3, or you will be able to go talk to your DynamoDB. Okay, your DynamoDB is your Amazon's own non-relational database, right? Sub-second or sub-millisecond, not sub-millisecond, but single-digit millisecond response time. So if you want to do that, then you can use this VPC endpoint. A VPC endpoint enables you to privately connect your VPC to supported AWS services. It doesn't support all the AWS services, but whatever the AWS services that it supports, it supported AWS services and VPC endpoint services powered by AWS private link without requiring an internet gateway. You do not need an internet gateway, NAT device, VPN connection, or AWS direct connection. Instances in your VPC do not require a public IP addresses to communicate with resources in the service. So your instances, your DB instance does not need, obviously it doesn't have a public IP address, but it will be able to communicate with S3. It will be able to communicate with your DynamoDB. Traffic between your VPC and the other services does not leave the Amazon network. It does not. your packet doesn't go out to the regular public internet. Endpoints are virtual devices. They're horizontally scaled, redundant, and highly available VPC components. They allow communication between instances in your VPC and services without imposing availability risks or bandwidth constraints on your network traffic. So what happens is you will create an endpoint. So the way you do that is go to your VPCs. Okay. Internet gateway. Click on endpoints. So you create an endpoint here. So a VPC endpoint allows you to securely connect your VPC to another service. So these are all the services that it supports. Let's say one of them is S3. So let's say I want S3. And then, okay, so now I need to be able to select which VPC you want to do it. Okay, I want to do it to my next prod. And then I have two subnets here. I have a private subnet and public subnet. So public subnet guy can go directly talk to S3. There is no big deal about it because there is an internet gateway anyway. So internet gateway is attached, so it will go to the public internet. Okay, it will be able to do it. But if instances in my private subnet want to connect to my S3 buckets here, they have to go through either NAT gateway or NAT instance. Well, instead, I can create a VPC endpoint for this S3, and then I'm attaching to this private subnet. Okay, and then it's asking, okay, what kind of policy do you want to allow full access? Yeah, go ahead and allow full access for this one. And I don't worry about S3 endpoint. Once I create the endpoint, what happens is now this endpoint got created and I attached it to my private subnet. Yes, I attached it to the private subnet, and private subnet is attached to my private route table. So if you go look at the route table in the private route, so you just wait for, it takes decent time actually. You wait for about 5 minutes or so. So what it does behind the scenes is that it will create a new route out, okay, to S3, to your VPC endpoint. So what it means is, without needing a NAT instance or NAT gateway, your DB server, which happens to be inside your private subnet, will be able to go out and then get the objects from your S3 buckets, or it will be able to upload the data into your S3 buckets because you have created an VPC endpoint and you do not need internet connection. It doesn't leave your Amazon network. So for all the supported services, you can create the endpoints and attach it to your private subnet. And if you're thinking of attaching NAT gateway just so that it will go upload or download some objects from your S3 buckets, you do not need NAT instances and NAT gateways. All you have to do is just create a VPC endpoint. That's the right way to do it because it doesn't go out to the internet. Packet doesn't leave the Amazon network. So that's about VPC endpoint. Any questions?
So at a company level, so if we want to do database updates, we will still need NAT gateway that we can add and delete, right? we will still need that NAT gateway, right? For any updates. This is just for S3, I mean, Amazon services.
Absolutely, absolutely. If you want to do, that's a very good point, actually. Yes. So if you want to do any other service, if you need any other service other than these VPC endpoints, okay, in this case S3, right? Similarly, DynamoDB, and we can go look at other services that it supports. If you want a general internet, like your sudo yum update, right? That needs a general internet. Then you have no option. You need NAT instance and or NAT gateway. In fact, good point. Yes. Let me refresh it. There you go. I refreshed it and got it. Did you guys see that? It automatically created it. So it automatically created a VPC endpoint and then assigned this route. Now your DB server will be able to talk to your S3 buckets. Now you can use your CLI. You can go AWS S3 copy, AWS S3 LS. You can do all of that. Okay. I mean, now probably I wouldn't know if it's going through NAT gateway or VPC endpoint, right? Go delete this guy. You understand what I'm saying? Go delete this route so that there's no more regular internet. Now log in to your DB server and now go try to do your S3LS, all of your CLI commands, try to create a bucket or try to add objects to your buckets and all. You will be able to do that. How are you able to do that to your internet one? Well, through VPC endpoint. VPC endpoint, yes.
Say you have both enabled on your database server, right? Say for VPC endpoint as well as your NAT, right? So now if I am trying to communicate with, say, S3 bucket, which would it pick? Would
it will pick the VPC endpoint as long as the packet is reachable through VPC endpoint, it will pick that.
So the order of precedence is always through endpoint.
Yep. Because it does not leave the Amazon network.
Okay, and the same kind of question goes, say, for example, I have a web application deployed on web server and it is uploading some files to S3. And I don't have a VPC endpoint. At that stage, it'll obviously go through the internet connection it has.
Yep.
But in such a example, would you still create an endpoint for web server?
Let me rephrase your question. So with your permission, right? So essentially, my web servers are in the public subnet. My public subnet already has an internet gateway attached to it. Does it still make sense to attach a VPC endpoint to that? So that when I interact with S3, I will not have to go through the public route. I will go through my VPC endpoint, which does not leave Amazon's network. Did I phrase your question correctly?
Yep.
Yes. Answer is to that question is yes. It makes sense.
Okay.
Yeah. So even though they're in the public subnet, I mean, private subnet, you totally got it. It makes a lot of sense, by looking at it. Absolutely. So you just, attach your NAT gateway, as Sindhu was saying, attach it only when you need it. Administration in all other scenarios, just attach your VPC endpoint and you're done, right? So does it make sense to do it at the public subnet also? It absolutely does. So that your packets are not going through the internet, and then you are mitigating the risk, right? As long as your packets are within the Amazon network, that's the route you wanted to go. Absolutely. Okay. Go ahead.
So you said, I think because of the the endpoints that we just attached, I mean, now we can go in to the database server and use the CLI interface and make, create S3 buckets or add objects, right?
Yep.
But we still will not be able to log into the database server, correct?
That problem is different.
Okay,
And
understood. Yep.
and that's not even a problem. That's design. That's exactly how we designed it, and that's how it should be.
Okay.
You should never be able to log into that without the hope, without the jump box, or without the Bastion host, or without your intermediate server. Period. That one, my answer will not change for that. Okay. So how are you guys doing with the time? I have another small concept called network ACL. I wanted to show you guys something simple. It doesn't take more than 10 minutes. Can we take it so that we can leave early? Or you need a break?
No, we can do it. I'm good.
So let's go ahead and do it. Okay, network ACL, right? So we talked about route tables, subnets, right? And there is another concept called access control list, especially network access control list. It's popularly called NACL, NACL, network access control list. So these are associated at the subnet level. These are like security groups. These are like virtual firewall, but not at the instance level. Security groups are at the instance level. If you have 20 instances, these 20 instances can have 20 security groups attached to that. I want you to understand that. Remember, when every time you spin up a new instance, in the end, it will ask you, do you have a security group that you want to attach it to or create a new one? You can create a brand new security group for every single EC2 instance. That's at the instance level, security group, what ports are allowed. But these network ACLs are at the subnet level. So you are defining the rules, and by the way, your routes are also at the subnet level. Your routes are created and then attached to the subnet. So your routes are essentially, they decide where the packets go. These network ACLs, they define the rules who can talk to instances within that subnet. Our subnet is not even in the picture. You can say this is a logical group of rules called network access control list. You will create a group of rules and then you give a name. And now you can attach this guy like security group. You can attach this guy to any subnet. Like how you can attach a security group to your individual EC2 instances. Your security group is nothing but a set of rules, set of allow rules. You create that, give a good name, and then go attach to any number of EC2 instances. Similarly, you create a good NACL, network access control list, define your rules there, and go attach it to your subnet. So these are at the subnet level. And the way they work very similar to security groups, but with a couple of differences. Okay, so let's go ahead and create NACL. By default, a network access control list gets created when you create a VPC. I want you to know that also. So by default, so this is for the default VPC, and this is from my next step prod VPC. Okay, so this is I'll call this as a next step prod default NACL. Okay, I'll leave this one. And this is like your firewall rules, as I said, exactly like security groups. But the difference is in security groups, if you remember, you can only allow, you cannot put any deny rules. But here you can define what inbound packets can come in and what outbound rules can come in. So you can allow it, you can deny it. If you want to deny a specific IP address, you can do it using NACL, Network Access Control List. You cannot do it through security groups. In security groups, you can only allow it. That's one difference. The second difference is, of course, the first and foremost difference is NACLs are associated to subnets. These are not at the instance level. These are associated to the subnets. And security groups are associated at the instance level. That's the first difference. The second one is you can only allow in security groups, but here you can define your allow rules and you can also deny, you can provide your deny rules. Meaning if you want to deny packets coming in from some specific IP address, you can do so using NACL. You can do a deny rules, okay? And number 3, the third difference is the security groups, if you remember, they are stateful, meaning if you write inbound rules, you don't have to mention the outbound rules. It doesn't matter what the outbound rule is. If you write the inbound rules, your outbound rules are exactly same. But here you can define who can talk to who from outside, who can talk to this NACL. Okay, you can define your inbound rules, who can come in, and you can also say instances within this subnet, who can talk to out, what ports can they talk to out, and inbound rules, who can talk to on the inbound. Does it make sense? All the instances are in a subnet. Okay, who all can access these instances in the subnet is inbound rule. The outbound rules is the instances in this subnet talk to what outside, what ports, okay, and what IPs. You can specify all of that. You can do it at the IP level also. Okay, so let's go ahead and define a new NACL. Let's leave the existing one. By default, this is created, the default one, and the subnet associations, both the private and public, they both belong to same NACL. What I will do is I will create a new NACL for my public one, and I will show you a deny rule, and then I want to deny my IP address specifically, and then I'll show you how it will be denied. So let me go and look at my web server. Web server has a public IP, and I'll go this guy. Hello from web server of public subnet, right? So I have a web server running healthy. Now I'll go to my VPC. I'll go to network access control list. I'll create a new NACL, and I'll say public NACL for my custom VPC. Next step, create. Beautiful, my public. Okay. So now let's define the rules. By default, when I create NACL, guys, the default one has all the rules. Rule number 100 says all traffic is allowed for all the IPv4 addresses. Rule number 101 is all traffic is allowed to all the IPv6. But this is what by default, when your VPC is created, a new NACL is created. When you explicitly create a new NACL, by default, everything is denied. Inbound is denied, outbound is denied. Okay, what it means? Now I created this new NACL. I'll go to the subnet association, and then I will associate to my public subnet. So I want my public subnet to be associated with the public NACL. Now, does it make sense what I did just now? I just created an empty NACL. It doesn't have any allow rules. By default, everything is denied. Now let's go hit this guy. It will struggle. It doesn't reach my IP. It will be denied at the NACL itself. Okay, it will go through your internet gateway. Internet gateway will say, will give it to the, let me show you that guy, right? My request will go to the internet gateway, to the router. Router will look at it, and then send it to send it to the appropriate subnet. And now before the subnet, there is a front guard. That guard is NACL. Okay, can you talk to? Nope, my NACL says that no inbound request, nope. So see this, you can't be reached. Now I will change it, I will allow it. Now what I will do is, by default everything is denied. Let's allow rule number. By the way, I'll talk about these rule numbers. Rule number 100. Nice, I would say HTTP to everybody. Go ahead and allow HTTP traffic to everybody. Oh, I did not put the outbound rule. Let's go ahead and put the outbound rule. Every single IP address, my public NACL, my subnet, public. Okay, let's go take a look at the inbound rules. My 100 HTTP, using HTTP. Let's go check this guy. My web server. Yes, this is correct only. My NACL is it's not allowing it. Okay. My VPC, network ACLs, my public, it's associated with public guy. Public NACL association, yep, public. Okay, this guy is in private. Okay, this guy is in public. And is it because of IPv6 by any chance? But okay, let's see if I change this one to all traffic. Okay, all traffic on all ports. Go ahead and allow that. Not only HTTP, all traffic. Allow that. Let's go check it. Okay, so but then why I don't need all traffic? Why do I need all traffic? I don't need I only need port 80, right? So what I will do now is, while we think about it, so I'll go ahead and add new rule 101, new rule. And here I can say that my custom, sorry, HTTP port 80 to be deny. Go ahead and deny only for my IP address. What is my IP? This is my IP. But I have to give it in the CIDR range. Somebody asked about /32 earlier. So this is how we do that. So I want to deny access only for my IP. Okay. only for my IP inbound and outbound both sides. I will deny HTTP only for my IP and now deny it. Oh, sorry, /32. Go ahead and deny this guy. Okay, now let's go ahead and try. So it's allowing it. How come I wanted to deny this, right? I want to deny only for my IP, but how come this rule is not getting affected? So the way network access control list works is that based on the rule numbers. I want you to really understand for the real life and also for the exam. So it goes from low number to high number in ascending order. Okay. So it does the rule number 100. If rule number 100 definitively says one way or the other, if it allows, the traffic is allowed. If it denies, then traffic is denied. It will not even go to the 101. So it will go from 100 to 101. So what Amazon recommends is that when you add a new rules, go ahead and put it in hundreds, 100, 200, 300, 400, so that when you have to adjust your rules somewhere in between, okay, I want this to be executed between 100 and 200. Then you can put at the time 101, 102, etc. So what I'm saying here is that my rule number 100, allow all traffic has been executed. That is why my request was allowed. So if I go and change the rule number from 101 to 99, so now 99 gets executed. My IP is denied, so it will be denied. It will not go to the rule number 100. Does it make sense? So I'll go to now this guy. Now it will be denied. But what I want you to try is, can you try this public IP from your homes? All of you will be able to do it except me. I'm sharing that in the chat window. Please try that. You should be able to go in, but I will not be able to. I'm not able to. Please try that for me. So essentially, you can deny specific IP addresses here. So you are not able to specify the deny rules in your security group. Security groups does not allow deny rules. Okay. So I saw some messages here.
Yeah, I'm able to access.
Wonderful, wonderful. So Uma said she was able to access. Yes.
Yeah, here we created our own public ACL, right?
Yep.
So suppose, but in next step we do have two subnets, right? So subnets also, if we are giving subnet to one ACL, we can't use the same subnet to another ACL.
That's correct. That's correct. So one NACL only can be associated to subnet. That's what you're asking, right?
Yes, yeah. That's what I observed.
Yeah. Yep. Only one NACL can be associated to a subnet. Like how one route table can be only one route table can be associated to a subnet, only one NACL can be associated to a subnet.
So it raises me one more question, like in next step prod, we remove the public subnet, right? So
we remove the public subnets?
Yeah, in the next step public.
Oh, this guy, the default one. Yep.
We removed it, right?
You got it.
So
see, only private is there. Yeah.
Yeah. So here, can I give the internet access to that private by this next step prod default?
Not fully understanding, but let me see.
Even I am also a bit confused because
we'll go logically. I think I got your question.
Yeah.
See this one here? By default, this is the default NACL that got created when I created VPC, right, Kalyan? And look at the rules here. My rule number 100 is all traffic to all IPv4 addresses, allow it. Rule number 101 is allow all IPv6 address. Outbound, allow all ports on to all IP addresses, allow it. Allow all ports to all IPv6 addresses from this box. Okay, inbound and outbound. So that means it is able to the complete. The rules are wide open right now. This box can talk to anyone, and anyone can talk to this box. Does it make sense? So that is the NACL rules on your private subnet right now. But still, you are not able to talk to private subnet because it doesn't have a route out. The rules are not the reason. Your NACL is allowing it, but it doesn't even get to NACL because your router itself is saying, I'm sorry, I don't have a route out. See here itself, your router itself is saying that, I'm sorry, I don't have a route. You can't talk to that guy. Does it make sense?
Yeah, correct. Yeah.
Okay, so your route table itself doesn't have a route, but there is no problem with the NACL. That is why by default, when you create a VPC, it is creating a default NACL with all the traffic allowed, because the assumption is that these guys would have taken care of those rules in the security group or the route table, but you can come back and modify them anytime. By default, I would say leave the default NACL as is, okay? Because, when I create new subnet association, by default, this is the NACL that gets associated, okay? But if you want the default one to be restricted, you can create a new one and make it a default. Does it make sense?
Yeah. In
so
my
the
previous
security, go ahead.
Yeah, my previous assumption is there like ACLs, we do have access entries, or these within the ACL we do have ACEs. My initial thought is ACE is nothing but two subnets, but it completely wrong, because as you said, like subnet, one subnet is only allowed to access in one ACL.
Rather than saying access, ACL is nothing but a group of rules with a label. That's all it is, Kalyan.
Yeah, I got it. Yeah, I mean,
okay.
The reason my understanding is, in the IBM world, ACL, ACEs, we pretty much use on daily basis. So it's completely wrong. Yeah.
Got you. And by the way, what is the other word you have used? ACL is one. What is the other one? ECA?
ACE, access control entry. Entry is nothing but like admin, like
I see.
ACL is combination of ACAs, like securities, like admin, read, like.
Gotcha.
But here it isn't different.
Yeah, ACL is a very standard term, right? Not specific to AWS, not specific to networking.
Yeah, it's a standard thing, but within that ACL, what we observe is subnet, right? When we are using subnets, one subnet is allocated to one ACL, we can't use it to another one.
Yep. Access control entry. Thank you for that. I learned something new. So yes, that's about NACL. So you guys are all able to access, I'm assuming, but I was not able to. So essentially you can put the deny rules here. That's all. Oh, by the way, the difference between security group and NACL will at least get you at least 1 or 2 questions in the exam. So these rule numbers, the rule number, definitely there will be a question on that. At least I had a question on that. So he'll just try to trick you, they will be executed in the order. The rule number order is essential point that we need to understand. Okay. And then you can deny it. That's the beauty. And these are at the network, subnet level, not at the instance level. So that's why all along, it doesn't matter what you put it at the security group levels. Security groups are at this level, at the web server level. But the whole, there are two more governing rules. One is at the router level, one route table for each subnet, and there is another one called NACL. Okay, so with that, VPC section is complete. It's by far the most important of all the topics. There is no doubt. By far the most important one, the most kind of cryptic also. It's a tough subject too. Okay, and I might plan on having a weekday session sometime in between. So based on your response, we'll see. So the next topic I want to attack is Lambda's function as a service. It's a serverless architecture, and it's a popular one. That's the most talked about architecture in the last couple of years, I think. It's not a big deal, simple. So remember we talked about the weather application. So we uploaded the weather data into S3, and then we made a REST call. That REST endpoint will grab the data from S3 and update into RDS. What we'll do is we don't do that. We will introduce a function there, cloud function, or function as a service. That's what they call it. Lambda, we'll write a Lambda locally, and then we'll upload that Lambda to through AWS Management Console. We'll upload the code, a simple jar file. I'll show you the examples in Java because that's the most familiar language for me. But there's nothing language specific there. Everything is language agnostic. You can do it in Python or Node, or you can do it in C# or any other language. So we'll do that. And then as soon as you upload object in S3, your code gets called. Your code gets invoked, and your code will take the data from S3, that weather data, and then dump it into the database. Actually, we'll not use RDS further because RDS is not supported in Lambda. So we'll have to use DynamoDB, the non-relational database. I'll show you all of that in the next one. Okay, that's all.
Venkat, quick question on this. Did you change the inbound rules as well, or just the outbound?
Sorry, can you say that again?
Yeah. Did you have to change the inbound rules as well?
Okay. I'll tell you about the inbound rules and outbound rules, right? Inbound rules are, can you hold 1 second?
Sure.
When I'm calling him, oh, sorry.
1 second, I'm sorry. Sorry about it. Okay. Sindhu, you're asking something?
Yeah, I changed the outbound rules. I added those 2 rules, but it's still not coming up, the web server. So I was wondering if you changed the inbound rules as well.
Okay, let's talk about inbound rule. I'm glad you asked that. Let's talk about inbound and outbound rules, okay? So inbound rules are from outside the world, who can talk to me on what port. Outbound rules are this machine can talk to who on what ports. Now you tell me what makes sense.
Yeah, I think we should just change the outbound rules.
Did you change the outbound rules?
Yeah, I did.
Right. So you have a web server, right?
Right.
So what's your objective? Is to allow the traffic from outside, correct?
Right.
So now you tell me, is it inbound or outbound? Let's talk. So you have a web server and you want to allow the traffic inbound into your web server. You want to take the request, correct?
Right. Yeah.
Does it make sense?
Yeah. Should be
And
changing.
now, if your web server wants to communicate with some other third-party websites on certain ports, I don't know how to stop this one. So if you want to communicate something out, okay? So if your web server needs to communicate with some other server on certain port, and that's when your outbound rules will come into picture. Did you understand that?
Yeah. Yeah. I got it. Yeah. I'll have to add inbound instead of outbound.
Yep. Did everyone got that? Did everyone get that? What I was trying to say there? 1 second. Can one of you help me how to? Go ahead, sir.
Yeah. See, in this rule, these are the number, but there are stars for the deny. What does that mean?
Oh, these are the default ones. If at all there's nothing that's specified here, these are the default rules that are applicable. If I take out this, these are the default rules that gets applied.
Okay, that's why it comes with the star. Okay, thank you.
And that's why, take a look at it. These are nothing but, these just in the UI, he's showing you by default deny, right? When I go to inbound, there's nothing there. There's no rule number called star. You understand?
Yep.
So these are the default ones by default that gets executed. Okay, guys. So that's all I have. And yeah. So I'm excited about Lambdas. And then we talk about API gateway. That's another exciting topic. And then pretty much after that, pretty much the ancillary topics, the small ancillary topics. Okay. I'm muting everyone. So yeah, that's all, guys. So have a great day and stay home, stay safe. I'll upload the videos. Okay, you can contact me, but I'll post homework also, because whatever we did, NACL and a couple of others, I'll mention there. Probably I'll prepare a complete homework for the entire VPC section. Yeah, Regu. Sorry, I'm muting it because there's background noise. Go ahead. Regu, you're saying something?
Yeah, so I was saying just the bullet points, just like yesterday.
Yes, we'll do that.
Thank you.
Yeah. Okay, take care, guys. Have a good day.
Thank you.
Thank you.
Thank you.
Bye.
Bye. Bye.